Artificial intelligence, AI. Real-time scenario-based artificial intelligence, AI, interview questions and answers Part 2. Question 1. How do you deal with imbalanced datasets in AI projects? Answer. Techniques. O. Resampling, oversampling minority, undersampling majority. O. Synthetic data generation, SMOT. O. Use algorithms robust to imbalance, XGBoost, random forest with class weights. O. Evaluation metrics prefer precision recall, F1 instead of accuracy. Scenario, in fraud detection, 98% of data was non-fraud. Accuracy looked high, but model missed fraud cases. We applied SMOT plus used recall-focused metrics, improving fraud detection rate. Question 2. Explain transfer learning with a real-world example. Answer. Transfer learning, using a pre-trained model on one task and fine-tuning it for another related task. Benefits: saves training time, requires less data, improves performance. Example: used ResNet, pre-trained on ImageNet, and fine-tuned it for medical X-ray classification. Instead of training from scratch, accuracy improved with fewer training samples. Question 3. What's the difference between online learning and batch learning in AI? Answer. Batch learning, train the model on the full dataset, offline. Works well when data is stable. Online learning, train model incrementally as new data arrives. Suitable for streaming data. Scenario, in stock price prediction, batch training fails because markets change daily. We used online learning models to adapt in real time. Question 4. How do you ensure an AI system is scalable in production? Answer. Use distributed training, Horovard, Spark ML. Deploy with microservices plus containerization, Docker, Kubernetes. Implement model versioning plus CI as CD pipelines. Use GPU or TPU acceleration for large-scale inference. Scenario: a recommendation engine serving millions of users was scaled using Kubernetes plus TensorFlow serving, reducing response time from 1.2s 300 milliseconds. Question 5. Can you explain reinforcement learning with a practical example? Answer. Reinforcement learning, RL agent learns by interacting with environment, using rewards, penalties. Example applications: robotics, gaming, AlphaGo, resource optimization. Scenario: in an ad placement system, an RL agent optimized which ads to show to maximize clicks. Over time, CTR improved by 22% compared to rule-based systems. Question 6. What are common challenges in natural language processing, NLP? Answer. Ambiguity, word meanings vary by context. Low resource languages, lack of training data. Bias in training data. Sarcasm, irony detection is hard. Scenario, in a Twitter sentiment analysis project, model misclassified, "I just love waiting in traffic," as positive. We solved it with contextual embeddings, BERT. Question 7. How do you prevent overfitting in AI models? Answer. Techniques. O. Regularization, L1, L2. O. Dropout layers in neural networks. O. Cross-validation. O. Early stopping. O. Add more data, a data augmentation. Scenario, in an image recognition project, model performed great on training but poorly in real world. Adding dropout plus data augmentation fixed overfitting. Question 8. Explain the role of embeddings in AI with an example. Answer. Embeddings, dense vector representations of data, words, users, products, that capture semantic relationships. Example. O word 2vec, glove, BERT embeddings for text. O user embeddings in recommendation engines. Scenario, in a movie recommendation project, embeddings helped map users plus movies into the same vector space, improving recommendations beyond simple ratings. Question 9. How would you monitor an AI model after deployment? Answer. Key areas. O. Data drift, input distribution changes. O. Concept drift, target label relationships change. O. Latency and response time. O. Model accuracy over time. Tools, MLflow, Prometheus, evidently AI. Scenario, a chatbot's accuracy dropped over time because slang words changed. We detected concept drift and retrained the model with fresh data. Question 10. What's the difference between deterministic and probabilistic AI models? Answer. Deterministic model always gives the same output for given input. Probabilistic model produces outputs with probability distribution, accounts for uncertainty. Scenario. Deterministic, rule-based spam filter, fixed rules. Probabilistic, ML-based spam classifier, predicts 80% spam, 20% not spam. Thanks for watching. Hit the like button if you learned something new today, and subscribe for more hands-on artificial intelligence, AI, content. Keep learning, keep growing.